Hello? All right. So that's a little loud. Hey, everybody. How are you doing? Quick sort of PSA. I guess the talk is really heavily going to focus on the cloud. So if you're not interested in the cloud, there's another really great session that's going on right now that focuses more on sort of more traditional on-premise stuff. So with that, let's go ahead and get started. So my name is Chris Patterson. I'm a program manager working on Team Foundation Server. Specifically, I work on the team build parts of Team Foundation Server and the Team Foundation service. And what we're going to cover today is we're going to go from essentially file new project, very, very close to file new project, to build an app, talk about the sort of technology decisions we're going to make along the way, the different technologies we use to build this app, all of which are some of the cool new stuff in .NET 4.5 and Visual Studio 2012, and set it up for continuous deployment out to Windows Azure. So we'll see if we can accomplish all that in 75 minutes. And to kind of get us started, what I want to do is show just a quick demo of where we're going to be. So I've got my super awesome task list application here up and running. And what I want to do is we're going to go into Visual Studio and make a quick change and see how this is going to work. So for this particular one, I'm going to, let me go to the layout here. I'm going to sort of follow that first task, and I'm going to fix the casing of my website just as something simple. So we know everything is supposed to be uppercase these days. So we're going to make sure we're following the proper rules. Make my quick change, and I'm going to go ahead and then check this guy in. Call it fixed casing. Check that in. Hopefully the internet will stay working. This will be important. And as part of that check-in, we've kicked off a continuous integration build. And one of the nice things here is I'm using the TFS service, the live service that's out there today. I didn't have to do anything to really set this up. On the service, there's a bunch of build controllers that are sitting there available to do builds of most of the applications that you can build in Visual Studio. Obviously, we're continuing to improve that over time. But in a second here, hopefully, it should get picked up. If not, this is going to be a really short talk. Come on. Oh, boy. All right. Well, while we're waiting on that, let's take a look at one that happened yesterday. All right, so what should happen is eventually a build controller will, from the cloud, there it goes, it will pick it up. Sorry, that was a little slower than usual. And pull down the code. Obviously, it will do a compile of my application. And it will take and run the unit tests that I have. And once all of that completes, it will actually take the package that's generated and deploy it out to Azure automatically. And I don't know if anybody's tried to do this before. It can be a little bit difficult to configure, but we've done a lot of work with the service and with the Azure folks to make this as easy as possible to make sure you can get going very quickly. So, so we can see it's building. It will publish in just a second. We go look here. If we go look over in our Azure portal, we can actually see under the deployments tab, we should get some feedback that we can see that there is actually a deployment happening. So we're getting sort of continuous feedback between the build happening, running tests. We can see over in our Azure portal that this deployment is happening. And in fact, even if we click the view log here, we get linked back to our TFS preview account. And we can see the detailed log of what's going on for the build. So it's a very tight integration between the two services. And as everything goes well here, finish running the tests. Okay. We'll eventually get a deployment. Oh, well, it's in the process of deploying, so my application is down. Come on. We'll come back up here in a second. And there we go. All right, so we made our change and deployed it out to the service. Simple change. We're going to do something a little bit more complex as we go through the session. All right, so back to slides for a minute. Hello. Try this. All right. So that's the demo where we're going to get. As I said, we're going to talk about our core technology choices. We're going to talk about dealing with data and data migration. Right? As you have any app that has a database, that's a pretty challenging thing. We're going to talk about some of the things we can do with unit testing, some of the new features of unit testing in Visual Studio 2012 that can help us keep that quality high. We'll talk a little bit about the application lifecycle, and of course we'll talk in more detail about what's going on with that automated build and deployment. All right, so application platform-wise, when you're talking about building an application from based on the Microsoft platform, you actually have a couple of sort of major platforms to choose from, really revolving around the private and public cloud. Obviously, if you've watched any of the sessions, the keynotes, some of the foundational sessions, one of the things that we're very committed to here is really providing you options and really the best of both private and public cloud. For this particular session, we are going to focus on the public cloud, so we did pick Windows Azure for that. And while that's sort of one level of the decision we had to make, even within Azure, there's sort of 3 different ways we could have chosen to deploy this particular application. There are Windows Azure websites, cloud services, and cloud services, you can kind of think of those as the traditional Azure applications that we've known for a while. And then, of course, these new infrastructure service VMs. One of the really great things about the cloud services is they're highly scalable, right? I'm building an application. I need to be able to elastically control how much I need for any given layer of my application, whether it's the web front end or different worker backends or queues or other of the Azure services. However, for our case, we wanted something kind of lightweight, easy to get going. So we chose to use the new Windows Azure websites, which is a new feature that was brought online about 3 weeks ago or so now. And the idea is you get a very simple way to set up, an not really just an ASP.NET, but a web application to run. It's going to be quicker, easier, less complex overall. So again, for our simple app, we chose a website. However, even once we did that, we had a couple of other options to make. And one of the ideas I threw around when I was working on this talk with a colleague is we said, well, we could do something really kind of crazy and maybe use PHP or Node.js for this application. And as we went through the different options and looking at kind of what we had to work with, we did end up settling on MVC4 and Web API to build sort of the front-end application stack. But we really truly could have gone with some other options. And of course, Azure is very committed to providing a great platform for your web assets, not only for stuff that is part of the Microsoft stack, but also other things. Like I said, Node.js and PHP are both fully supported in these new Windows Azure websites. So let's get started writing some code. So what I'm going to do, let's open a project here. So I've got a task list project. We'll open up. And it's got a couple of, let's close our build. It's got a little bit of work already done. Not significant, just a little bit. So if I just quick F5 this thing. Oh, come on. running its local host. Basically, it's just the UI. So the only thing I've done with this application so far is I dropped in the HTML because I really don't want to write HTML. And you can see I've got my same bug about the title casing here. So maybe we'll fix that along the way. Well, to get started with my app, what I wanted to do is I said, okay, I want an application, I want a task list, but I really want it to be very modern. I want to have the browser be the client, running JavaScript, getting data from the server. I want the API that it's using on the server to be accessible to lots of different clients, so I could build, I don't know, an iOS app or a Windows Phone app or a Windows 8 Metro app and actually use that same API. So how would I do that? And the way I chose to do that is I was looking at the different technologies that are available. We could have used SOAP with ASMX Web Services. We could have used MVC controller actions to sort of mimic a REST API. But with MVC 4, there's this really great new feature called Web API. And Web API is all about building these new modern web-based APIs. So I'm just going to say, you know, create, right-click, add a new controller. I'm going to call it our tasks controller. And for now, I'm going to make it just an empty API controller. And you can see it's very similar to the MVC controllers, just has a different base class. But that gives us a lot of really interesting things to work with. So to kind of show off the basics of that, I need something to return. So I need some sort of object, given we're doing a task list application. I'm going to create a little task model, a very simple one, and we'll give it 3 properties. Property int, call this one ID, give this one a string title, and then we will give it a Boolean for whether or not it's done. Okay? So a very, very simple model. Now I need to create some way of getting that model back to my browser. And the format that the browser is asking for is JSON, right? So there's a couple of ways I could have accomplished that in the past. Now, one of the really, again, nice things is all I have to do with Web API is say, you know what, I want to return a non-enumerable of task. Task, import my using there. We're just going to call this get tasks. Okay? And then I'm going to, just for starts, I'm going to return a new list of task objects. And then let's add a couple to it. So new task, ID is 1, title, my task, and is done equals false. And just to make it a little more interesting, we'll go ahead and add a second one. It's 2, title equals my second task. And make the is done equals true for this one. All right. So make sure this compiles. Good deal. All right, so now that I've written my little basic API here, let's go ahead and see how this works. All right. Oops. Where's my local host? Here? Hello? There we go. All right, so browser came up and it filled in our UI. All right, we can see that we've got a little bit of work going on here, but what actually happened under the covers? So what I'm going to do is I'm going to bring up the browser tools here and go to the network tab, start capturing, and click on refresh. And if we go, does anybody use the F12 tools in the browser a lot? Good. They are awesome. So if I look here at this bottom guy, so let's bring up the zoom. Or is it zoom or magnify? Magnifier. Okay. Let's go down here. All right, so we see down here at the bottom, we see the call to our /API/tasks route. And this was done automatically for us by Web API. So it knows that, hey, I've got an API controller. There's a default route there, so everything that goes to API routes to API controllers. And we can see that the type here is application JSON. And if we go look at the response body here, we can see it did actually return JSON. Now, you'll notice I didn't have to do anything to make that happen, right? And that's one of the, again, the really great features is Web API knows how to handle that for me. It's called auto content negotiation. In fact, if I went and said, to say another browser, and let's go ahead and look at that same URL, /API/tasks, we can see we actually get XML back in this case. And this is because the default behavior of Chrome is to do application XML as the requested type. And also, we noticed that this responded to a GET request and did the right thing. So the idea here is, instead of me having to think deeply about the configuration of what's going on, or the fact, hey, in this case, my client wants XML, or in this case, my client wants JSON, the framework is taking care of that for us. It's using strong conventions, so get, put, post, take a look at that, to understand which HTTP verb to respond to, and then using built-in information inside the stack to say, okay, which content type do you want? And all I have to do is think about my logic and my model objects. And of course, all of this is extensible, so you can control things if you want to. All right, so to kind of fill this guy out, let's go ahead and do a couple of things. So first thing I'm going to do is I'm going to insert a snippet just to kind of finish filling out my task controller here, just so we don't have to think about it much. And then I need some place to get those tasks. So I'm going to use a really common pattern called the repository pattern to give me a fixed interface to work with whatever the persistence backend is that I'm using. And for now, I'm just going to use just an in-memory list. So we'll call this our task repository. And we will insert another snippet so you don't have to watch me type quite so much. Just a basic in-memory task repository. And then up here we will say task repository repo. We will give ourselves a quick controller, constructor, sorry, from our controller. Constructor, and then we'll say repo equals new task repository. Okay. And then finally, we'll go here and make sure instead of returning our little array, our little list here, delete, we'll return get all as enumerable, because the get all is actually returning a not queryable. All right. So let me go through and talk about what's going on here. So you'll notice that I've got a few more methods, and each of these correspond to, again, an HTTP verb that I want to deal with. So in the case, I have a post task that'll respond to the post verb. And you'll notice that within it, I'm working with these HTTP response messages, and there's also an HTTP request message. What this does is, this means I'm basically separated from the actual HTTP host that I'm running in, right? So I can work purely with HTTP. I can deal with the response codes, the status codes, things like location, without actually having to use like HTTP context.current, right? So this is going to make my controllers much more unit testable, as we'll see later on. So if I've done everything properly, I can go look at my app again. For some reason, Visual Studio keeps wanting to steal focus. And let's go back to my network tab, start capturing. I can say, adding task. We can see that a post went across. And if I say maybe update and save, we can see that a put went across, right? So everything is working. We now have a task list. If I refresh this guy, right, it's going to come back and it's going to work. And And a Web API is letting me just work with JavaScript in the browser, call these APIs, and it's taking care of all of the good content negotiation for me. So that's just kind of so that's sort of a brief overview. There are other sessions that talk about Web API in more detail, which if you're interested in it, I think you should talk about. So let's go back to our slides for a minute. All right, so we've got our app started. However, it's just using this in-memory repository. Obviously, for any kind of real application, it's probably not going to be very effective overall. Application server recycles for whatever reason. All our tasks are gone, not very effective. But we have at least got the basis of a good API and front end. It's using solid configurations, or solid conventions, so I don't have to change that if I go to a different environment. So as I deploy, as I move through dev, test, production, I don't have to worry about lots of XML configuration files and other things that tend to get out of sync. The next thing we're going to talk about is persistence. So in this case, we have a couple of different options that we could use. In fact, actually, I want to talk here. Let's go back. One of the features that's been around for a little while, and as part of the overall data stack, is this entity framework. And they keep working on it. They keep advancing it. It keeps getting better and better. And it is what we've chosen to use for persistence for this particular application. But there are a couple of different ways I could have chosen to work with entity framework. And the way I sort of break them down, the way I look at them is designer-centric versus code-centric, right? So, and then even within that, there's a couple of different options. So if I'm interested in the designer, I like designers, I want to drag boxes on there, set properties, create relationships between my entities, I can certainly do that. And I can do it either by creating the model first and then having it generate the database, or I could choose to have the database first and then reverse engineer that model from the database. And either way is fine. It just depends on where you are. Are you greenfield? Do you have a new database you're working with? Or is it something existing that you then need to kind of map this layer into? The other option is, you know what, I'm a developer. I like to write code. I don't really like to work in designers. And I am of the opinion that I like my model, my domain, to sort of drive what my database looks like versus the other way around. So in this case, I'm going to take a very code-centric approach. And in fact, because I have a new database, I'm taking a complete code-first approach. So instead of using an existing database and kind of reverse engineering my classes or defining the mappings, I'm going just to let, again, convention drive what my database looks like and what the structure of the schema is, and then how it's going to be mapped in there. And once I've done that, I have a second thing to deal with, which is, okay, you defined your data layer, defined my model. I've defined how I want to map it. Well, how do I actually get that thing deployed? And more importantly, how do I deploy schema updates? Like as I go through the application, we're going to add something. And from that perspective, you have a couple of options as well. The most powerful option that gives you the most flexibility and gives you the ability to make, I guess, the fullest use of SQL Server really are the SQL Server data tools. They're, I guess, if you ever used the DB Pro features that existed in Visual Studio, I guess 2008 and 2010, this is kind of the logical successor to that. It is a slightly different method of working with it. It's a lot better in many ways. But the idea is I want to use stored procedures. I want to use inline functions. I want to use table-valued functions. I want to do all of these different, very powerful SQL Server things. Then I need to have tight control over my schema, so I need to write the tables, write all the schema myself, and I want to deploy it. So that's what SQL Server Data Tools is all about. The other option is to, pardon the pun, sort of keep your application on rails and just go forward with this code-first approach that we're taking with this app, and I'm going to use entity framework migrations. Now, what this lets me do is it lets me, again, define my database in code. I can define the schema in code, right? We talked about that with my models, but I also want to define how I migrate in code. I define what my up and down scripts look like. I want to control it, how they execute, but I want to do that with code, C# code or VB code instead of SQL. There are some limitations with this approach, unfortunately. Right now, it doesn't really work with stored procedures or functions. You really are limited to sort of creation of tables, creation of indices, creation of foreign key relationships. And then you're going to use just regular transact SQL with no stored procedures that's generated for you by the framework. All right, so let's go back to our application and talk a little bit about adding some data. All right. So in this case, we have our application. We've got our model, right, our very simple model defined with a few different properties. And so what I need to do is I need to somehow say, all right, I've got my model. I've got to map it to a database. And to do that, I need to create a database context. So I'm going to add another class. Just call it our task list context. And I only have to do a couple of things to kind of get this set up for the simple case. So we're going to inherit from DB context, which is a class that's defined as part of the entity framework. Oh, and out of curiosity, the way I got the entity framework was through NuGet. So you go to, anybody familiar with NuGet? Is everybody using NuGet? Good, it's awesome. Makes finding all of these various different frameworks and the updated versions that we produce on a regular basis really easy. And I'm using the RC version in this case. It's a little bit different from the beta version, so you want to make sure that you're forward to the entity framework RC to do these things, to make it, or at least work the way I'm doing it. And in this case, I need to define a couple of small things. So we're going to define a constructor for our task list context. And as part of that, we're going to just call the base constructor. And what we're going to do is we're going to tell it that we have a connection string that we want to use. So we've defined, I have a connection string defined in my web config. And once I've done that, all I have to do is just create a property and have return a DB set, generic one task, and we'll call this tasks. Okay. And that's really it. So I've defined that here's a database connection. So there's some database connection out there called task list context. It's pointing at a database. And it has an entity set that it can return called tasks of type task. Now, once I've defined this mapping, again, using conventions in this case, but I could do a lot more if I wanted to configure more, I need to tell the framework about this model and how I want to sort of instantiate it into the database. And to do that, I'm going to switch over to the Package Manager console and use some PowerShell scripts that have been provided by the entity framework. And these come down with the NuGet package. And the first thing I'm going to do is I'm going to say enable migrations. And so this PowerShell is going to go through and inspect my project looking for all of the classes that inherit from DB context. And then it's going to create this configuration class for me that gives me a couple of different methods. So it's going to inherit from DB migration configuration. It's generic type of task list context. In this case, automatic migrations are not enabled for this particular configuration. So this is kind of a nice case for the development side because I'm explicitly running migrations with code. We'll see that in a second. But I could simply turn those on, and every time I run my app, when this configuration loads, it's going to automatically migrate. And we'll see how to do that for our production deployment or test deployment a little bit later on. The other thing I could do is I could optionally seed some data in. So if I didn't want to start out with an empty database, I could shove some data in. This, incidentally, is also really effective for unit testing. So I can, if I want to run unit tests, or I guess really integration tests, with Entity Framework, I can create a different configuration as part of my test project. It looks exactly like this, and provide that. And maybe I do want to seed data, right, in that case, because I'm running integration tests. I want to make sure that I have a fixed data set that I'm testing against, so it can be very effective for that. So it really, again, providing these frameworks does give you the right plug-in points and the right kind of Lego pieces to make everything come together in the end. All right, so I have my context. I've got my configuration, and now I need to actually add some migrations. So to do that, I do another command, which is cleverly named add migration. And I just give it a name. In this case, I'm going to call it initial. And what it's going to do is it's going to, again, inspect and say, do a comparison between, okay, what does the existing schema look like, which was empty, and then what does your model look like now? And so it's going to say, okay, well, what do we need to do to create that, to get our database up to date? So we're going to create a table. We're going to call it DBO tasks. And then I get to use some nice lambdas and code in here to say, okay, this thing needs a column called ID, and here's the type, and a title, and type, and is done, and type. And then, again, via configuration, it just simply says, okay, well, I think you have something called ID, so I'm going to call that the primary key. Of course, all this, again, is controllable. I could go do other things like create an index. So if I wanted to create an index on a particular column, I could do that. And have a fair amount of control. And then finally, I want to eventually run this guy. So what I'm going to do is go update, update database. All right. So now what I'm going to do is just call write update database, and it's going to take the migrations that are defined. It's going to look at the level of my sort of local test database and apply the necessary migrations. And so at this point, I now have a database locally, and I could go look. Let's bring up the Server Explorer and look here. I think. Look at my tables. And we can see we have our task table, right, all defined there. All right, so now I need to actually talk to this database. So to do that, I'm going to take advantage of some of the work I've already done and kind of expand it a little more. So we're going to go back to our task controller. And you know, as we mentioned, I have this API, I have this repository that I built. Well, unfortunately, it's just a memory repository, but I do want to use the interface. Like the interface is the definition of the contract here. So what I'm going to do is I'm going to go back to my task repository, and I'm just going to simply refactor it to extract out our interface. Call it iTask repository. Hit OK. It's public. All right. And then I'm going to create a new model here called our DB task. All right. And then we're going to implement that interface. All right. Again, to sort of save a little bit of time, I'm going to insert a snippet here. Oops. And it's helpful if you don't try to put a class inside of a class like that. So let's get rid of this outer braces here. That one. All right. Again. So it's just a very simple, pretty standard repository pattern. So now I have my database repository. You notice all my unit tests ran. We'll get to that in a second. And then I want to put this into my controller. And there's kind of a couple of different ways I could do that. For now, I'm just going to say make that an iTask repository, and then just say, you know what, I want this guy to be a DB task repository. It's all set up. And hit F5. And bring up our browser. And hopefully, all right, so we have no tasks. So, okay, let's get rid of these guys. We don't need this right now. It's great. Okay, isn't that? Save it. Good. Refresh. All right. So we went through, and now instead of talking to our little in-memory repository, we're actually talking to a database. We did a little bit of refactoring work in there. We'll kind of get to why that's important in a few minutes. But the key thing is we were able to kind of keep the approach we wanted to, right? We drove everything through code. We're relying on our conventions. We're not really configuring a lot. And all these things, as they add up, are going to make it much easier to kind of deploy this application and hopefully maintain it, as we go into the future. All right. All right, so that's adding data. The next thing we want to tackle is testing. So we've built our application a little bit. We've kind of started to get some functionality in there. But the thing we haven't done yet really is build any tests for it. So to do that, we have, again, more options. Don't you love it? There's all kinds of choice here. But one of the great things about this particular choice is there's no advantage or disadvantage across the board. We worked really, really hard with Visual Studio 2012 to make unit testing really, really great for developers. And as you can see there, effective unit testing is the biggest contributors to high-quality software. It's true. It just makes a big, big difference in how really your developers think about quality, about driving quality into your software. And kind of to extend that, the other way I look at it is if you have a build, an automated build, and you don't run unit testing, well, you're not building, you're compiling, right? The compiler is just the first unit test. And one of the struggles that a lot of our customers had with previous versions of Visual Studio is, we had a test framework. It was decent. It had some good functionality, but it wasn't the one they wanted to use, right? Unit testing is very important. It's also a very personal thing for a lot of developers. And if you force people into using a particular framework that they don't want to use for whatever reason, sometimes it just makes it less enjoyable and they want to write less tests or they don't feel like they're as effective with their testing. So in this case, Visual Studio 2012, including Team Build and Build in the Cloud, have support for a lot of different unit testing frameworks. And out of the box, well, there's MS Test, obviously, but you can also use NUnit and XUnit as well as others. In fact, more and more of the leading frameworks out there the authors are creating adapters for our unit testing framework, and so you can run them nicely inside Visual Studio. But also, the other thing you need to do is provide, in order to have effective unit testing, high quality, you've got to provide for good architecture. So one of the biggest things you can do for that is really just factor out those external dependencies. Unit testing is great, but if I run a unit test and I have all of these external systems or dependencies, whether it's databases or message queues or whatever that I have to deal with or get set up in order to run that test, well, that's really an integration test, and it makes it very hard for unit tests to run fast and be consistent. So trying to make sure you're factoring out these systems appropriately using things like the repository pattern and interface that we talked about can make that better. Now, however, when you do factor those out, you have to have a way of getting the right one in there when you're running the app. So one effective pattern for that is your dependency injection. And there's a lot of different frameworks out there for doing that. If we get time, we'll use one of those. And the other thing you have to do is, but when I'm testing, I need something to talk to, right? I've factored out this interface, but what am I going to call? And for that, you can use isolation frameworks like MockU or RhinoMox, or in this case, we're going to use a framework called Fakes. And Fakes is based on the moles work that was done by Microsoft Research, and it's been deeply integrated into Visual Studio. And again, it worked with any of these unit testing frameworks. So within the Fakes framework, there's something called stubs and mocks. We treat them a little bit differently, and we're going to talk really a bit about stubs mostly today, and not so much about mocks. But the idea is it provides easy-to-use concrete implementations for your testing. They're generated at compile time instead of runtime, which means they should be faster overall. And it just uses sort of generic C# language features, so there's no real special API to deal with. And I think this makes it a little bit easier to use. So, how can we unit test our application? Well, the first thing I want to do is, we notice we actually already have a few unit tests, and these were kind of generated by default. They don't really do a whole lot in this case, but they are using MS Test, in fact. However, because I just did file new project, I said, hey, I want a new test project. By default, they're MS Test. In this case, I don't want to use those. I actually want to use XUnit. I'm going to show you how to do that. So I'm going to add another project here, and I'm just going to make a class library, and I'm going to call this task list.xunit tests. Okay? And we're just going to get a normal empty class library. Well, to turn these into XUnit tests, I need a few references. So what I'm going to do is go ahead and add a reference using NuGet. I'm going to search for XUnit. A little faster, please. Goodness. All right, so we're going to look for XUnit. We're going to install the xunit.extensions package. And this is obviously going to go pull down all of the dependencies we need for XUnit. And I'm also going to, because we're using Web API, we're going to be testing Web API, I do need a few things. So I'm going to go ahead and install the ASP.NET Web API assemblies into my unit test project. All right, so those are all downloaded for us. And then finally, I need a reference to, obviously, our task list controller. So I need this project reference. And then I'm going to be using something from system.web. All right, system.web. Okay, check that off. Hit OK. All right. So a couple of seconds, and our unit test project is ready to go. I'm going to rename this guy to be our tasks controller tests. Oh, OK. So what do I want to test? Well, there's obviously a lot of different things. If we kind of go look at our task controller here, we see we have a number of methods. But in this case, I want to, I'm going to focus on the post method here. And I want to say, all right, so I look at the implementation or the behavior of my post method, and I see what happens. Okay, well, I pass in a task. It calls my repo, says, hey, save or update this task. And then, which in this case it's a post, so I know it's a creation of a new task. It saves, and I say, okay, well, it saved, so I want to return, following good REST standards, the fact an HTTP created status code to say, hey, it was created, and then the location URI. So we're going to see how we can test this thing. And so we'll just say to method void post should return HTTP created. All right, I like longish method names. I don't like underscores. So that's how I'm going to write my method there. And then to make this guy a XUnit, test, all I have to do is define that as a fact. If I build it, we can see over here in our test view that it popped right up. So how did that happen? Well, all I had to do to make that work is I went to the Visual Studio Extension Gallery, and I said, I searched for the XUnit runner for Visual Studio 2012. And what this is an extension to the test runner framework that gives it knowledge about how to discover and execute XUnit tests. There's one of these for NUnit. There's one coming for MBUnit. There's also one for the QUnit JavaScript testing framework. And I can't remember the name of it off the top of my head, but if you just search for, I think search for QUnit on the extension gallery, you'll find it. So, we have testing frameworks for .NET as well as JavaScript. They all run together, and you can have these unit tests that run inside one single framework, and then of course that integrates also with TFS and with TeamBuild, so it really gives you this nice end-to-end overall experience. So now I've got to actually figure out, okay, what do I want to do? So I need to whatever, arrange, act, assert, right? Kind of good, rough unit testing practice. So for arrangement, I'm going to need a task equals new task. So I need something to post. So in this case, we want I don't need a system.threading task. That's not going to be very useful. I want one of my tasks. Oops. So in this case, it's a new one, so I know the ID is supposed to be 0. Call this just new task. And is done is going to be equal to false. All right. So I have a task. Well, the second thing I need is an instance of my controller to call, and this is where it's going to start to get interesting. I could just obviously say tasks controller. New tasks controller. But if I go and look at this, one of the problems I'm going to have here is, well, this news up a new DB repository, and that's going to be problematic, right? If I'm really thinking about unit testing and really pinning down the behavior of this particular controller, I don't actually care about the database in this case. It's not important to what I'm testing. So what I really need to be able to do is I need to be able to give this guy some sort of other implementation. So I'm going to just create another interface here. So say this dot repo equals repo. And I've gone ahead and left the other one in place, right? Because from the standpoint of kind of just going through and building up our application and doing things as we need them, I want to leave the default. This is called default implementation. I want to leave it the way it is because things that are already using the controller in my system, I want them to stay the same, right? I'm not ready to change that behavior yet. So I'm really just going to focus on this new constructor that I'm going to use for my unit tests. Okay, so now I have this new constructor that I need to pass a repository to. And, well, I need an instance of a repository. So we'll leave this in place for a second. And again, I have a couple of options here. I could actually go create one. I could maybe use my in-memory repository, which would be an option. Or the other thing I can do is I can say, well, I actually don't care anything about the implementation of that repository at all in this case, because really this is testing, unit testing. I'm really just trying to pin down sort of the overall behavior. What I really want to do is just say, look, I just want to know that when post is called, save or update gets called on my repository, and I get back my HTTP created message here. All right. So to do that, sorry, I didn't talk about it. I just simply went and I found the reference to my task list application here, and I said add fakes assembly. And what that did is it generated this new assembly. We see this new reference called testlist.fakes. If I view this guy in the object browser, it actually went through and generated for each namespace, for every public non-sealed class, so classes and interfaces, it generated this new implementation of it for me, right? And this is basically just an empty implementation. So in this case, I look at my models.fakes. I have one for my iTask repository. So great, all these stubs, and then also generate these things called shims. Shims are, stubs are basically fake implementations. Shims are what's referred to as monkey patching. Has anybody ever heard that term, monkey patching? Essentially, what a shim lets me do is they're very useful but very evil. And the idea is I can replace at runtime the implementation of any particular object, which means that I could shim date time if I wanted to. I could, anything in the framework anywhere that is publicly accessible. I could go to system and I can say, you know what, I want to change how datetime.now works, right? It's a value, right? It's a value type, so I can't inherit from it. So a stub won't work, and I can't override .now. But what I can do is I can say, well, hey, when now gets called, actually do this thing here. So that's what shims let me do. And you can see how that could be problematic. They're very, very powerful, but be careful with them. Again, there's a Peter Provost has a more in-depth talk on unit testing, which goes over some of these things. So anyway, so I have my stubs that I added, and what I want to do is, okay, I need a repository. So I'm going to say stub task repository, right? Whoops. Is that right? No, let's try this again. Task list models fakes dot stub task repository. Okay, there we go. Equals new stub. There we go. Okay, so I've newed up one of those, and now I need to, again, using my nice initializer syntax, I need to actually provide an implementation. And if I control space here, you can see what it gives me is it went through and said, okay, show me all your public methods. And then it takes and creates these methods which are equal to public method plus the parameter list, right? So if I had overloads, right, for these methods, I would have one method that matched each overload. In this case, what I'm wanting to do is I'm going to say, okay, save or update task. So this is the save or update method that takes a task. And what I want to do is I want to say this is equal to task, which is the parameter that's being passed in, such that new task, which is the object I created up top, equals task. So what this syntax is saying is, hey, for this guy, when save or update is called, I want the task variable that you return and pass in to be equal to this new task object. So that makes sure that I have the object that I set up, that I arranged, is the one I get back when I call it. And then I need to then pass this repository into our controller. Except for, okay, so I've got my controller set up, I got my repository. There's actually one more thing I do have to do. And this is related to the fact that, so Web API is separated from the container, but there is obviously the container does some setup for me. Right? When I go through, it goes through all of the layers of routing, it creates controllers and creates configurations and all that sort of stuff. So I need to make sure that's there. So I have a method that I've written here, which is going to set up my controller for testing. And I will talk about what this method is doing here in just a second. Let me do all my imports here. HTTP route data. Routing, okay, and at some point we're going to figure out how to mock and stub this stuff away. But the idea being here is that I have this sort of hierarchy of objects that things rely on, but I can go create those. Like I don't need the server to do it for me. So I've got an HTTP configuration. I've got a request message, right? This is the request that's coming into my controller. I have some routing information. Actually, probably what I would do in a real world is I would just factor out my routing logic, right, where I set up all my routes, and I would make sure I'm using that same logic in both places versus splitting them, because if I go change this default route, now I've got to change it in my test. This probably wasn't very good, but it worked for here. And then just the route value information I need to set. So there's just a little bit of work going on here. It's not overly complex. But once I've written this method once, I could actually fairly easily make this generic and just say, hey, here's a controller type I need, and here are the parameters I want you to pass to the constructor, and just have this factory out the controllers from my tests. And so here I'm going to say controller equals setup, controller for test, pass it the repository here. All right, so I've got that guy all set up. I'm going to act on it. So I'm going to say HTTP response message, because that's what I want to check here. Response equals controller dot post task, and then we're going to pass our new task in here. All right, and then I'm going to assert equal response dot status code is equal to HTTP status capital HTTP status yes code. Come here, status code. Oh, sorry, SDATUS. This is why pair programming is a good thing. Dot created. All right. So let's see how we do here. So I'm going to build. Hopefully, so we can see that up in the upper left-hand corner, it started running. So I don't know if you noticed there was a little cancel there, and then it actually went ahead and ran our test. We can see this time my test took a whole lot longer. It took 660 milliseconds, but it did pass, right? So it's going through this whole process of creating a controller, setting it up, called it, returned the right status code, and everything is working. So we're now effectively testing our controller. And we could use this same method. We could test all of the methods. And what we've really done is we've locked down the behavior, but not worried so much about the implementation because, again, that should be hidden from me. What I care about is the behavior, not the implementation for this type of test. All right, so we've got our test running. We have our application kind of working. We've got it working against the database. We've got some tests. How do we actually get it deployed? All right, so here comes the fun part. So what I'm going to do is, actually, I'm going to attach to a different team project here. And we're going to do our task list demo here. Let that get connected here. All right. So I'm going to just simply add this guy to source control. Let's call it task list. That's fine. And then we will go over to our pending changes and say, all right, I want to go ahead and check this in. So this is normal check-in. If you've used TFS, this is pretty straightforward, standard stuff. All right, so I've checked everything in. Now I want to deploy it to Azure. And how do I do that? So what I'm going to do is I'm going to go over to my Azure portal here. This is the nice new portal. And I'm going to create a new website. Actually, I'm going to create it with a database. And we'll call this our task list demo. Should be used. And I want to create a new SQL database in this case. Name task list demo. 1 gigabyte. We'll use, let's create a new database server to go with it. We'll call this, say, give it a password. Region East US. Okay, that's fine. And so what Azure's going to do is it's going to go out and say, okay, I need a new website, create one of these new websites, and I need a database to go with it, and it's going to relate them all together. And hopefully Visual Studio, okay, so that was pretty quick. All right, Visual Studio has checked everything in. And now I need a way to actually deploy from TFS, from the TFS service to Azure. So to do that, I'm going to go to the dashboard page for this particular application. There's a new button here called Set Up TFS Publishing. And so what that's going to let me do is it's going to simply say, okay, you have a TFS preview account. It's mine, chrispat.tfspreview.com. I want to authorize Azure to talk to that particular account. So it's going to go through a quick OAuth flow for me. And so authorization successful. And then it's going to give me a list of the team projects that I have in that project. And then I'm going to hit check. And what it's going to do is, so I authorize Azure to talk to that project. So Azure's going to use that OAuth credentials to go configure my team project for deployment. It's going to give it a cert, one of the management certs for Azure, so it can authenticate with the Azure backend. And actually, it's also going to create a build definition for me that knows how to deploy to Azure. So if I go back and look at builds, I now have this task list demo build application, build definition, that if I go look at this build definition, because, again, just trying to use some simple conventions, if I go look at the actual process here, all right, we can see it's gone ahead and found the fact that I just have one solution in here that should be ready to build. Okay, so it's ready to deploy. I'm actually going to change this from continuous integration to manual here for a second. And that's really all I have to do to get deployment configured, right? Really simple. Now, one more thing I do need to do is on deployment, I want to make sure that the connection string, right? So I've been using my Entity Framework database. I have a connection string that is pointing at a local database. Obviously not going to work very well in Azure. So I need to make sure I get the right connection string in place. So if I go look at my dashboard, there's this download publish settings profile. our published profile here. I'm going to download that guy to my local machine. And if I go into Visual Studio and right-click on my web application, I can see this publish method, or publish menu item. And what I want to do is I simply select those publish settings, and it's going to import all of this information for me, including, because I have that linked database, the connection string. So what I want to do is I want to select my connection string here and apply code first migrations. Whoops, dang it, I did not want to do that. Didn't mean to publish from here. And I don't know how to cancel it. In fact, can I cancel this? Nope. All right, well, that's going to happen. That's fine. Hit the wrong one. At any rate, it's created a couple of published profiles here. It's okay. I should be able to redeploy right over top of it, and that'll be fine. And all I need to do is go check those guys in. So again, we will go ahead and there it launched our application. We'll see that publish from Visual Studio works here in a second. What I really want to do is I can't get through them all without some kind of demo field. Isn't that just terrible? All right, so we're going to say adding publish profile. Go ahead and check that guy in. All right, so we have our published profile. And then if I go back to the build section, I need to, actually here it is, here. Oops, manual. Save that. I want to go to the process tab here, and I just need to tell the build about that published profile. So this makes sure that when the build happens and the deployment goes through, the right config transforms happen. So I get the right connection string in my web config. So let's go back and look and say, yep, that appears to be working. All right, so deployed from Visual Studio. Because we already saw it deploy, I'm actually going to go through sort of one more iteration here so we can see a new feature. I'm not going to run the build definition yet. But decided this is the exact same thing I did for the demo at the very beginning. I did the same process. I set everything up. I walked through the wizard. I told it the publish profile, and it worked. Well, let's see how we would add a new feature to our application using everything that we've set up. So I'm going to go back just for fun. We'll be dangerous and change this guy to a continuous integration trigger. And let's go back to our task list. And so one of the important things missing from a task list is priority, right? You got to have priority. I'm a program manager. I want these things done when I want them done. So let's add a priority field. Well, first thing we need to do is we need to go tell our model, hey, you now have a priority field. So we'll call this guy an int. All right, so that's done. Cool. Build that. That's great. And then once we've done that, we need to tell our database about our priority field. So what we're going to simply go here and say add migration priority. Okay, enter. Sweet, good. So we have a new up and down script. And then for our local quick testing, we're going to call it update database to update our local one, because we want to monitor this as part of development instead of having it happen completely automatically. And then finally, we got to make sure it shows up on our view. So we'll go look at our view here and say, okay, let's add in again another snippet, which is just our priority select list. So this is going to, just set up a new select list here. And if I did all that right, should be able to refresh this guy, or F5 this guy here. And pray. Ooh. Okay. Well, so that happens sometimes. So let's go through and, again, use our nice F12 tools to clear our cache. Clear browser cache. Oops, you know what I forgot to do? I forgot to add the priority field to our JavaScript, right? So it can't bind it here. So let's go to our scripts here and pull up our task list JS, and really quickly we'll say this dot priority equals ko dot observable If anybody hasn't used the JavaScript IntelliSense in Visual Studio 2012, it's unbelievably good. So I'm not a JavaScript programmer, but I can kind of make do here. All right, so we did that. Let's run this guy again. Let's hopefully it will work this time. All right, so we now have a priority column, our priority select list. We can update that, F5 it, awesome. All right, so that's working. So we have our priority done. We would probably write some tests in the real world, but just for sake of time, I want to go back to my pending changes and go say, okay, I want to exclude these guys. I don't want to check my database in this case. And we'll go through here and say, okay, so added, all right, check this in. All right, so checked in our changes. And again, we moved that guy back to a continuous integration. So we can see it actually automatically kicked off a build for us. Really standard CI kind of thing. So we have a few minutes left. We're going to let this run. We've already watched it run. Hopefully it will go and complete nicely for us. But let's kind of go through and sort of finish up our slides, and then we'll see everything going. So what do? We used a lot of really interesting technologies to build a pretty modern website, right, using Ajax and having a nice web API. We talked about how we can drive quality in via some good architectural practices. We showed how we can unit test. Even though we have a nice separated architecture, we can drive good unit tests through those things. We can unit test with our own framework. So really all these things, everything we've done boils down to having the fewest moving parts possible. Really, that's that convention over configuration thing. So don't have a bunch of XML files, et cetera, lying around. Driving in good quality through architecture, as well as making developers comfortable with the quality choices you're making. Right, having the ability to use the unit testing framework of my choice is a big win in my opinion. Other things that we might want to do is obviously iterate. Right, we want to keep kind of going this process. We want to decide that very minimum feature set that we needed to do. Right, we had a pretty tiny feature set, so we got our task list out there. We added the next one. We got it out there. So we're continuously deploying very small features and continuously testing very small features. While it's not always possible, it certainly does make it much less likely that something weird will happen. Right, the bigger the change, the bigger the chance for problems. In fact, as we've been building the TFS service, this is a big thing we've noticed. Previous versions, we had 2+ year long development cycles before anything gets delivered. But with the service, we deploy every 3 weeks, and you would think that becomes a burden, but actually it's so much easier on the developers, and it's so much easier on the QA teams because every change is smaller. That means there's less to regress. There's just less things that can go wrong, and the developers know that this code I'm writing, somebody's going to see it really soon, which means that they feel much more invested in the quality of that code than they ever were before. So all of these sort of things kind of just build towards that continuous delivery ideal. So let's go and see how we're doing here on our deployment. So it's building, and we're running tests. Okay, let's let it go on here. So it's actually running, again, it's running the build. It's not just running my MS test, it's also running those XUnit tests for me, okay? So it's published the output to MS Deploy. So let's go ahead and take a look at our website. Right, here's our, oops, that's not the one we want. We want to go to the task list demo site. So there's this one. Let's click Browse here. And remember, this is the same one that we initially published from Visual Studio by accident. We should have published, and so there's our task. We can see we have our priority list. Save it. All right, let's refresh this guy. All right, so we've deployed it out. The database schema migrated. Everything is still working. Right, we just simply checked in. The build was configured. It deployed. So we're, in this case, we're really continuously deploying to a test environment. Right, that's the idea here. So we can constantly validate. You could, as you mature and as you feel comfortable, apply the same principles to production. It's kind of an interesting sort of further part of this discussion. But with that, I'm done, and we can take questions. Any questions? All right. So I will be here for a few minutes. There's a lot of other great content out there for other sessions that cover kind of more depth about sort of some things that I went over at a very high level here. So thank you.